Welcome to Math 10, our first lecture. On these videos, you are welcome to pause it at any time and try the question on your own. Now let's get started. Sue and Ann earned the same amount of money, although one worked 6 more days than the other. That's important information, so let's highlight that. We know one person worked 6 more days than the other. If Sue earned $36 per day, and Ann earned $60 per day, how many days did each work? Well, the first thing we have to figure out is who worked more days. If they made the same amount of money, who worked more days? Well, it has to be Sue because she earns less per day. So we know Sue's going to work 6 more days than that of Ann. And when we try these problems, we could use algebra or we can use guess and check. Here I'm going to make a table. There's many different ways to solve the problem. I'm going to start by making a table. So let's suppose that Ann made $60 per day, so I'm going to make a list of days. We'll figure out how much money she earned altogether. So let's put the days 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll figure out how much money she earned for those days. So simply just multiply 1 times 60 and 2 times 60 to get the total amount of money earned. You can try that on your own and we'll compare our answers. And here is the amount of money earned for the days, so double check with yours that you have the same amounts. Now I know Sue worked 6 more days than that of Ann. I know Sue worked 6 more days than that of Ann. So if Ann worked 1 day, Sue would have to work 7 days because it's 6 more than 1. So we'll check for 7 and then we'll continue our process from there. 7, 8, 9, 10, 11, 12, 13, 14, 15. And this could be a tedious process, but we know for sure we're going to eventually get to the correct answer. And so now let's multiply 7 times 36 to figure out the total amount of money earned, 8 times 36, and we'll continue the process. So double check with me that you got the same numbers and try it on your own. Alright, so the last one's 540, and that finally matches one of our numbers here. So we can see that Ann has to work 9 days, and Sue has to work 15 days to make the same amount of money. So we'll put that somewhere on the side. Sue works 15 days, and works 9 days. Now this is a tedious process, but it's just one method to get the solution. We of course could create a system of equations and we'll be able to get the numbers also using Algebra 2. Let's try problem number 2. Draw a diagram to solve. For his wife's birthday, Mr. Jones is planning a dinner party in a large reception hall. There will be 22 people, and in order to seat them, he needs to borrow card tables, the size that seats one person on each side. He wants to arrange the tables in a rectangular shape so they will look like one large table. What is the smallest number of tables that Mr. Jones needs to borrow? So try this problem on your own. Draw some pictures and make your rectangular table and see how many tables we need to seat 22 individuals. First thing I want is to draw some diagrams, and we'll just do this randomly, but we need to make sure that we can seat 22 people. So let's draw a table, and then we're going to make sure to add enough tables so we can seat 22 people. And here I have chosen to use 10 tables forming a 1 by 10. So I know that On the ends, I have one person each, and then on the sides here, we're going to have 10 individuals. 10 plus 10 is 20, plus 1 gives us 22 people. So this arrangement does see 22 people, and I use a total of 10 tables. So that's a good start. Now let's try another arrangement. Let's start with 2 tables, and then we'll keep adding until we make sure to seat 22 individuals. And again, this is just a sketch, so it doesn't have to be perfect. And I have here a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 tables on the top row, and the second row has 9, so 18 tables altogether. Let's make sure we can seat 22 individuals. We have 2 on each side, and on the top here we have 2 plus 2 is 4, 9 plus 9 is 18, 18 plus 4 gives us 22. So yes, this arrangement does work, but we used more tables. So we're looking for the smallest number of tables, so this doesn't work. So let's try another one. Let's try a 3 table row now, and we'll figure out how many tables we need altogether to see 22 individuals. Okay, so I have 1, 2, 3 by 8 here, so that is 24 tables. It doesn't seem like it's getting any smaller, and we can seat 3 on the left, 3 on the right, 8 on top, 8 on the bottom. So that is 22 individuals if you count all of the people seated around this rectangular table, but it doesn't look like it's going to be smaller than 10 tables. So that's our solution. We know the smallest amount of tables we need to borrow is 10 tables. As soon as we increase the row number of tables, we need more tables to see 22 individuals. So we only need 10 tables. That's the smallest amount we need. Let's try question number 3. I'm going to use a technique called guess and check. We're going to guess some numbers and check to make sure it works. A textbook is opened and the product of the 2 facing pages is 6,162. What are the numbers of the pages? Well, let's consider the first page and the second page. I know the first page is unknown. Let's give it a name. We'll call it X. The second page, I'm going to call it X plus 1 because the second page has to be one number larger than the first page number. Now it says the product, which means multiplication. If I take X and multiply by X plus 1, I should get 6,162. And now we can use algebra if we wanted to by distributing the X, setting it equal to 0, and using the quadratic formula, if we remember that formula from Algebra 2, or I can use guess and check. I think it's faster to use guess and check, so I'll do that. And let's look at numbers that are consecutive. When you multiply them together, you get 6,162. So pause the video and try to guess the two numbers that when you multiply them together, you get 6,162. The numbers that I guessed are 78 and 79, and if you multiply that with a calculator, you do get 6,162. So that's our two numbers. The two numbers is 78 and 79. So I know the pages, 78 and 79. Let's look at question number 4. Place the whole numbers 1 through 9 in the circles in the triangle so the sum on each side is 17. There is going to be multiple answers for this question, so give it a try and see if you can find some numbers that work. 17, 17, 17. Alright, and it took me a while, but here are my numbers. Here are my numbers that actually work. 2, 8, 4, 3. That adds up to 17 going this way. And 3, 7, 6, 1 adds up to 17 going this way. 1, 5, 9, 2 adds up to 17. So these numbers work in our circles, but remember, try it on your own. You should most likely get different answers than mine, and we're using the guess and check method, and it does seem to work. Question number 5. Sasha and Francisco were selling lemonade for 25 cents per half cup and 50 cents per full cup. At the end of the day, they had collected $15 and they used 37 cups. How many full cups and how many half cups did they sell? For this question, let's try to use algebra. I know it's 25 cents per half cup. And I know it's 50 cents for 1 cup. And we made $15 altogether. And we sold a total of 37 cups. So let's set some numbers. We'll look at the number of 1/2 cups and the number of full cups. I'm going to give the name for 1/2 cups as X, and the number of full cups, I'm going to call that Y. I know there are 37 cups total, so I can say X plus Y has to be equal to 37. And now our total value has to be $15. For each of the half cups, we charge 25 cents. So that's 25 cents times the number of half cups we sell. So that's how much money we're bringing from the half cups, plus 50 cents for the number of full cups we sell, and we sell Y full cups, and that should add up to $15. Now we have two equations, and of course from Algebra 2 you can either use substitution or elimination to solve for X and Y. I'm just going to use substitution. For the first equation, I can subtract Y to both sides. Let's subtract Y to both sides. This gives me X is equal to 37 minus Y. And now I could substitute this value into our second equation. This gives me 0.25 times 37 minus Y plus 0.50 Y equals 15. Let's multiply this out using distribution. And so we have 0.25 times 37 is 9.25 minus 0.25y plus 0.50y equals 15. We'll collect like terms. And so this is 9.25 plus 0.25y, and that's equal to 15. We'll subtract 9.25 to both sides, and this gives us 0.25y is equal to 5.75, and finally we can divide both sides by 0.25. Divide both sides by 0.25, y is equal to 23. So we need 23 full cups. We can now plug in this number 23 into the equation 1 for the y, and we'll be able to solve for x. So I have x plus 23 equals 37, Let's subtract 23 to both sides. And x is equal to 14. So we have 14 half cups. Now, if you're not so good with Algebra 2, it's okay. We rarely use system of equations. You can always use guess and check for this problem also. So don't worry if you're iffy on Algebra